Hey everyone, have you ever written some Delphi code that just felt sluggish, but you couldn't quite put your finger on why? Well, today we are diving deep into the Delphi Performance Playbook, which is based on the amazing guide by Primoz Gabriel-Cich. And listen, this isn't just about a few clever code tricks. It's about building a whole new mindset, one that makes speed a core feature of your applications right from the very beginning.
Now, I know what you might be thinking. My computer is an absolute beast. Why should I even care about this? The answer is actually pretty simple. It's all about the user experience. Even on the fastest hardware out there, inefficient code can lead to those annoying, frozen UIs and super frustrating delays. Performance isn't just some extra thing to bolt on at the end. It's a critical, central part of modern software design.
So how do we actually get that speed? Well, the old way, that was to dive down and write low-level assembler code. And let me tell you, that was a slow, buggy nightmare. The Playbook approach is the complete opposite. It's not about tiny micro-optimizations. It's all about writing smarter, high-level code and building performance into your architecture from the get-go.
All right, so here's our game plan for today. We're going to kick things off with why performance is still a huge deal. Then we'll cover the golden rule: measure, don't guess. After that, we'll get into the two-level optimization playbook, talk about the awesome power of parallelism, and finally, wrap it all up with a summary of best practices. Let's do this. So, what does performance actually mean? I mean, really. It's not just one thing. For your user, it's a UI that never freezes. For you, the developer, it might be a batch job that finishes in seconds instead of minutes. And for a server, it could be handling thousands of connections without even breaking a sweat. The very first step is to define what fast really means for your application. Let's get to the single most important rule in this entire playbook. I mean it. Measure, don't guess. You simply cannot improve what you don't measure. Trying to optimize your code without data is like trying to navigate a new city without a map. You're just driving blind. This is where tools like profilers and concepts like algorithmic analysis become your absolute best friends. Okay, to really talk about performance like a pro, we need a common language, and that language is Big O notation. Forget about measuring things in seconds. That changes with every computer. Big O tells you how your code's runtime is going to grow as your data grows. It is the ultimate way to measure how scalable your code is. And this slide right here, this is where it all just clicks. Just look at that O(n) square row. When we go from 1,000 items to 100,000, the operation count doesn't just go up by 100 times. No, it explodes to 10 times billion. Meanwhile, look at that O of log n algorithm up top. It barely even notices the increase. This right here is why your choice of algorithm is the single most important performance decision you will ever make.
So we get the theory, right? But how do we actually apply it? Well, the playbook gives us a really simple two-level strategy. And this hierarchy, this order of operations, is the key to getting the biggest possible performance wins with the least amount of effort. Now, the most crucial takeaway here is this: you always start at level 1. Always. You can get 1,000-fold speed improvement just by changing your algorithm. You might only squeeze out a few percentage points by fiddling with compiler settings down in level 2. Seriously, don't even think about level 2 until you have absolutely perfected level 1. In this example just perfectly illustrates the power of level 1. Take a standard T-string list. If it's unsorted, finding an item means you have to check every single one. That's a linear O(n) search. But if you just sort it first, you can use a binary search, which is O log n. The difference? For 1,000,000 items, we're talking about 1,000,000 comparisons versus about 20. It's the same data, just a different approach, and they are worlds apart in performance. Okay, now let's look at a classic level 2 optimization, the kind of thing you'd only worry about after you fix the big stuff. A Delphi record with just simple types like integers and floats is lightning fast to copy. But if you add just one managed type, like a string which needs memory management, the compiler has to inject slower background code. It's a really subtle detail, but it shows how even the internal makeup of your data types can have a real impact on speed. So far, we've been focused on making a single stream of code run faster. But the biggest performance leap you can make today comes from doing many things at once. It's time to unleash the parallel power of modern CPUs. I mean, just think about it for a second. Your phone, your laptop, maybe even your watch has multiple CPU cores. But by default, your Delphi application uses only one of them. That means you're leaving 50, 75, maybe even 90% of your computer's power completely on the table, totally unused.
The modern way to handle this is to shift your thinking from threads to tasks. As you can see, managing threads is like being a plumber in this tangled mess of pipes. It's super complex and really error-prone. Tasks, on the other hand, are the what. You just define the job that needs to get done, and you let a library like Delphi's parallel programming library handle all that messy plumbing for you. And the best part is, you don't have to reinvent the wheel every time. Modern libraries give you these powerful pre-built patterns. For example, say you need to process 1,000,000 images. Don't write a normal for loop, use a parallel for loop, and the library will automatically split all that work across all your CPU cores. These patterns are elegant, they're safe, and they are incredibly powerful.
All right, let's bring it all together. This isn't just a collection of random tricks, right? It's a whole new way of thinking about how you write code. It's about building a performance-oriented mindset from the ground up.
So, here it is, the performance playbook in a nutshell. First, make performance a design goal from day one. Always measure before you optimize. Master Big O so you know how your code will scale. Choose the right data structures for the job. Fix your big algorithm problems before you even think about tweaking your code. And finally, when you need that maximum speed, go parallel with high-level tasks and patterns. And that brings us to the final question I really want to leave you with. Take a hard look at your own projects. Is your code just scraping by? Is it fast enough for now? Or is it truly performant, designed for efficiency, for scalability, and for an excellent user experience right from the very beginning? The choice is all yours.